Welcome back to another one of my sessions. In this session, we will be looking at solving simultaneous equations by the method of substitution. The method of substitution is an important one, and it is especially useful when solving a pair of equations when one of them is not linear. Now, using this method to solve a pair of linear equations will therefore provide a good foundation for learning to solve more complex simultaneous equations later on. This method involves 3 steps. I have listed them out here for you. The first step is to choose one of the equations. Then we make one variable the subject of the equation. And then thirdly, we substitute this equation into the other equation. Here I have provided a pair of simultaneous equations. So I'm going to follow these 3 steps in order to solve it using the substitution method. Remember, with any simultaneous equations, I must always label my equation. So this here is my equation 1. And this here is equation 2. So my first step says to choose one equation. Now by examination, the first equation is a better choice because we can easily isolate x. Meaning that I can have x on one side of my equation very easily by moving this 3y across to the other side to become negative 3y. So I'm going to do that using equation 1. I'm going to write back my equation 1 here. X plus 3y is equal to 7. X is equal to 7. Take away 3y. I have now made my variable x the subject of my equation. I have done step 2, which is to make one variable the subject of the equation. Now that step 2 there, with making one variable the subject of the equation, simply means that I want one variable, and in this case my variables are x and y. I want either x or y alone on one side of my equation. So there you have it. X is on one side alone, and I have x being equal to 7 take away 3y. Now my final step is to substitute this equation into the other equation. So I used equation 1, so I'm going to have to substitute this equation now into my second equation. Wherever I am seeing x in my second equation, I am going to be substituting 7 take away 3y. So I will write that here, substituting x is equal to 7 take away 3y into equation 2. So I'm going to write equation 2, which is 2x plus 5y is equal to 8. 2, I'm going to substitute that expression that I got there for x wherever I have x in my second equation. So I'm going to be substituting now 7 take away 3y. 7 take away 3y plus 5y is equal to 8. Now I put that expression into brackets because 2x means 2 multiplied by x. So if I'm substituting an expression for x, I need to multiply that now by 2. So I will get 7 by 2, 14, take away 2 3s are 6, y plus 5y is equal to 8. I simplify now, I get 14 negative 6y plus 5y is going to give me negative 1y. That is going to be equal to 8. Now I have an equation with one variable in it to solve for that variable. So I'm going to get negative 1y is equal to 8, take away 14, that is negative 6. And if negative 1y equals negative 6, I'm going to get y being equal to negative 6 divided by negative 1. I'm going to get 6. So there you have where you have solved for one variable. Remember, in a pair of simultaneous equations, there are two variables that needs to be solved. So what I can do now is take that answer that I got for that one variable and substitute it into any one of your equations to find your second variable. So I'm going to be using my first equation. So I'm going to write here using equation 1. I'm going to write back my equation 1, which is x plus 3y is equal to 7. Now that I know the value of y, which is 6, I'm going to use that 6 and substitute it wherever I see y. So I'm going to get x plus 3 multiplied by 6 is equal to 7. X plus 6 multiplied by 3 is 18 is equal to 7. X is going to be equal to 7. Take away 18. That's negative 11. So there you have it. You have solved your simultaneous equation for both variables using your substitution method. And we will just double check to make sure our solutions are indeed correct. If x is equal to negative 11 and y is equal to 6, it means that we have negative 11 plus, that's 3 multiplied by 6, which is 18. I have 7. So it works for my first equation. Let's try my second equation. That's 2 multiplied by negative 11, that's negative 22, plus 5 multiplied by 6 is 30. Negative 22 plus 30 is 8. So it works for my second equation as well, and that is how we know that our solution to our simultaneous equation is indeed correct. Don't forget to like and subscribe for more of my videos.